All right, this video is going to cover law of sines. So, law of sines is going to be a way that we can figure out the measure of a side or an angle. It's just kind of another way to do that. So, what will happen is you'll be given something similar to this over here, if I can circle it. So, you'll be given a triangle that looks like that. So, that's just what this given triangle ABC means. So, if we have that, basically the law of sines says that sine of A over A, which is just it's like the side of or sine of an angle over the opposite side of that angle, which is like this would be A and that would be sine of A, or that would be sine of A, and then the opposite side here would be A. So the opposite sides go with each other. The opposite side of the angle is what you'll be looking for. So if we know parts of this, we can set up sine of A is equal to A equal to sine of B over B, or it's going to be equal to sine of C over C. Basically, all of those are equal, and we can set up a proportion with those and solve it, and we'll be able to figure out the missing measure. So basically all that looks like is like this. It's not as hard, I guess, as it looks or as it sounds. I mean, it's not easy, but it's also not as difficult as it looks just on the surface. So I'll try to break it down so they'll make as much sense as possible. And then here, I mean, we don't deal with it much, but this is just more explanation of like what we're doing essentially. Kind of it's like our reasoning. So the law of sines can be used to find the side and angle measures given two angles in any side, or angle, angle, side, or angle, side, angle, or two side lengths and an angle outside of them, which is side, side, angle. So first we're going to be looking when we're given two angles and a side length, and we're actually looking for a, a side length, the other side length. So here you don't really have to worry too much about like A and B. What I want you to do is find each of your angle measures and set up a proportion with sine of each of those angle measures. Now, if we set both of those up, they're going to have denominators. Now, the denominators are just whatever the opposite side of that angle is. So like sine of 34, the opposite side of 34 is 10. So we're going to have a denominator of 10 over here. And then if we want what the denominator for sine of 52 is, we're just going to start here and go opposite side of that, and it would be x. So now you can see how we've set up a proportion. So for some of these, the only other thing that's going to change is they may give you these angles here, but you won't have an opposite side for that angle. So in that case, you'll just have to figure out what the missing angle is by adding these two together and then subtracting that from 180, because a triangle is the angle measure of a triangle is equal to 180. So we could figure that out, but we'll look at an example of that. But if you just set it up like this every single time, it's going to work. And then if you set it up like this and you don't have an opposite side, that's an indicator that you need to find another angle by doing what I just said do. So this can work pretty much all the time. Now, when you have two fractions or two proportions or ratios on each side of an equal sign, if you remember, we discussed that you can just cross multiply. So here we would have 10 times sine of 52 equal to x times sine of 34. Now, we're looking for x here. So essentially what we have going on the right side is x times sine of 34. So if you remember, if we ever have x times anything and we want to get rid of it, the way we get rid of it is by dividing whatever it's multiplied by x, and that'll get x by itself. So if we divide here by sine of 34 on both sides, it will cancel out the sine of 34 over here on the right, because anything divided by itself is just 1. And then when we simplify this, we'll get x is equal to 10 sine of 52 over sine of 34. Now this portion, you're going to plug in your calculator. You'll just have to watch out what you're doing. So if I were you, I would plug in this top part first. I would say sine or 10 times sine of 52. Then I would take that and divide it by sine of 34. But if not, you'll just have to make sure you put parentheses around this part. So if you do 10 times sine of 52 and end your parentheses and then divide by sine of 34, it should be okay. We'll look at some of that in class when I actually have the calculator where you can see it. But once we do this, we'll get 14.1, which would be our answer. So that's pretty much what you do here with these. You set up a proportion for yourself, and then it's pretty straightforward with how you do it. Now make sure you have this written down because I want you to at least see number 2 or another example. So I'm going to erase all this. So make sure to pause and get this written down. All right, we're going to look at number 2 just so you can get another example of one of these just so you can see it because I don't just want to give you one. All right, so on number 2, we have 2 side measures or 2 angle measures. They gave us a side and then they left out a side length. So we're going to use everything everything we have here to figure out what x is. Now, you could go ahead and check to make sure they give you an opposite side here. You could just go to your angles like 119 and go opposite. So they gave us x as an opposite, and then they also gave us, if this will erase, they also gave us, this is 21. If we go opposite of that, it would be 7. So they gave us the opposite sides here. We don't have to do any kind of calculations to figure out a missing angle. We have everything we need. So we're going to start off with sine of one of our angles. So sine of 119. And if we want to know what's going to go on the bottom of that fraction, we will, if it will work with me, and I'm actually doing this a different way just so you can see that there's more than one way to do it. But we can start off at 119 and go opposite of that, and that'll give us the denominator for sine of 119. So then that's going to be equal to, we're going to do the same thing with this angle 21. So we've got sine 21 over the opposite side, which is 7. So now we have our proportion set up. So then we can cross multiply here. So if we do that, we'll get 7 sine 119 equal to x sine 21. All right, now if we want to look at this further, so what we have going on here is on the right side, we've got x multiplied by sine of 21. So anytime you have x multiplied by something and you want to get rid of it or get x by itself, you will divide because that's just the opposite of multiplying. So we're going to divide sine of 21 on each side, which will get rid of it on the right. So we'll get x is equal to 7 times sine 119 over sine 21. Now you're going to plug this portion in your calculator and you will get x is equal to, let me check, 17.1. So our side length here would be 17.1. So when they're given to you like that, they're pretty straightforward. You just set up a proportion almost like this would look, except, I don't know, you don't have to worry too much about what A and B and C are. Just because it's going to work this same way every single time pretty much. As long as you take one of your angles, make it sine of that angle, and then make the other one sine of the other angle, or equal to sine of the other angle, your denominators will come from the opposite sides of whatever your angle measures are. Now, we'll look at one where it doesn't work out nicely, but it's not a hard part to deal with. But most of the time, or some of the time, you're going to already be given the opposite side. Like in 119, the opposite side was x, so x becomes that denominator. And then the same thing for 21. 21 degrees, the opposite side was 7, so we use 7 here for our denominator. So it's really all it is. Now, we're going to look at one where they don't give you the angle you need, and I'll show you how to figure that out. So We could already set up a proportion here or attempt to, and you would notice this. Or if we do it like number 2, we could just start off and make sure that they gave us opposite sides for each of our angles. So if we start at 64, we would have the opposite side of 32. That's nice. But if we look at 45 degrees, they didn't actually give us the opposite side here. But if we were to know what this angle is here, we would have the opposite side x. So here's how you figure that out. The measure of this entire triangle is 180 degrees. So we would say 180 degrees minus this angle plus this angle, because then whatever's left over after we subtract both of those from 180 degrees will be that angle measure. So 64 plus 45 is, let's see, that would be, I'm not sure. I don't have my calculator either. What would that be? That would be 9. That would be 109. Yeah, I didn't trust myself to do it in my head, but I forgot I'm a wizard. All right, 180 degrees minus 109 degrees is going to be equal to 71 degrees. So the measure of this angle that we need is 71 degrees, which let me zoom in so I could actually put it in there. 71 degrees. All right. So now, if you see, we have 64 degrees, and the angle opposite of that would be 32. And then we have 71 degrees. The angle opposite of that would be x. So we have everything we need for our proportion. So we don't really care about this 45 degrees anymore. So we're going to say sine of 71 degrees, and its opposite side will be the denominator. So opposite of 71 degrees would be x, and that's going to be equal to sine of 64 degrees over the opposite side of that, which would be 32. Now we have our proportion, and we just multiply. So we're going to say 32 times sine of 71 equal to x times sine 64. Now on the right side, we've got x times something. We want to get rid of that something, which is sine of 64. We want to get x by itself, so we will have to divide sine of 64 on both sides. That's going to get rid of it on the right. Then we'll get x is equal to 32 sine 71 over sine 64. Then x, after you plug this into your calculator, x will be equal to 33.7, I think. Let me make sure. Yeah. So we're saying that sine or side x here is equal to 33.7. So that's how you apply your law of sines. Now, I'm going to show you another part of this where, so this first part was dealing with like angles, angle, side, or angle, side, angle. Now we're going to look at side, side, angle, which is a little tricky. But hopefully the way I explain it won't be too bad. So what we have to watch out here for is ambiguous cases. So there's going to be some cases here that won't work. I'll show you how to deal with it. If you just know this process, you should be okay. So sine, the sine function always has a range between -1 and 1. If the sine function is positive, then the angle can lie in 1 or 2, quadrant 1 or 2. So as you see here, it says we can have one solution, two solutions, or no solution. So to find the other possible angle, we're going to subtract what we find from 180, which this will make sense. This is all just definition stuff. It'll make sense when we work problems, so don't freak out. So to find the other possible angle, we're going to subtract what we find from 180, and then the sum of the angle measures is always going to be 180 degrees. So no triangle can have two obtuse angles. Can happen. So that's essentially what we're going to do. What we're going to do is we're going to find an angle measure, and then we're going to use that, subtract it from 180, and then we're going to kind of test out if we might possibly have no solution or if we have more than one solution. So let's look at number 7. Now on these, I don't know. I wish they set it up with a triangle already. But on each of these, you're going to have to draw yourself a triangle. And I do it the same way every single time. So you could do that if you wanted. I try to always make mine the exact same way just because, I don't know, I don't like thinking about it. So here they tell us we have a triangle A, B, and C. So here's what I always do. I always start out drawing myself just a little triangle here, and I label this side or this angle. I say this is A, this is B, and I make the top part C. So then we're going to plug in everything it tells us and figure out what we're left out. We should probably end up with something that'll be pretty nice. I think on all of these you do. So measure of angle A, which is here, that's going to be 50 degrees. So we know that this is 50 degrees. AB, which is just from here to here, that side length is 4. BC, which is here, is 9. And then it wants us to find this angle. So it wants us to figure out what angle C is. So we can call that X. If we don't know it, we can call that X degrees. So what we're going to do is we're going to set up our law of sines proportion, except now instead of having a side left out, we have this angle left out, but we can do it the exact same way. So here's how it'll look. So the first thing we'll do is say sine of 50. So sine of 50 degrees. And that's going to be over the opposite side of 50 degrees, which is 9. And that's going to be equal to sine of x, because here x degrees is filling in for our angle measure. So now we're going to say sine of x is equal to, and the opposite of that would be 4. So it's over 4. Now we have our proportion set up. So this is pretty much how this will work. The only weird part is, I don't know, it gets weird in a few places. So if we want to multiply here, cross multiply, we'll get 4 sine of 50 degrees equal to 9 times sine of x. All right, so now we want to get sine of x by itself first, because I'll show you how to deal with this. It'll make sense once we get there. So we want to get this sine of x by itself first. So this 9's multiplied by it, so if we want to get rid of that 9, we're just going to divide by 9 on both sides. And we'll get sine of x is equal to 4 sine 50 over 9. Now here's what I'm going to tell you to do, because it just makes life easier on you. Go ahead and put this in your calculator. So that will give you sine of x is equal to, and we're going to round to 4 decimal places with this just so we get a more accurate answer. So this will round to 0.3405. So round that to 4 decimal places. Now, if you remember, when we have sine of theta or sine of x, and we know what that's equal to, we can set up x is equal to, or whatever inside of this sine, we can set that up to the inverse sine of 0.3405. So that's a part that can get a little weird. Now, x is going to be equal to 19.9 degrees. All right. So we figured out that this could be, well, probably is going to be 19.9 degrees, but here's what we have to do. So with these, they didn't really give us an accurate triangle, so there could be more than one answer. So, or we could test this number, and it could be no solution. So here's what you're going to do. You're going to give yourself a little bit of room, and you're going to say, first of all, you're going to say 180 minus that angle you just found. So 180 minus 19.9, because that's going to possibly be your other angle. So that would be 160 degrees. Or I guess it would be 160.1, wouldn't it? No, it'd be, what would that be? 119, that'd be 20. That'd be 150. It'd have to be 159.9 or 0.1. Yeah. Maybe I'm crazy, but I could swear that's what it should be. Let me make sure. I'm losing my mind right now. All right, 180 minus 19.9. 180 minus 19.9. It's 160.1. I'm crazy. All right, so 160.1. So this could possibly be our other angle, but we're going to have to test both of these. So here's how you test it. So if we go back to our triangle, this entire triangle should be 180 degrees. So if we if we add two of our angles together and they give us more than 180, that can't happen. So we're going to start off with 50 degrees and add that with 19.9 because that's just like saying this side or this angle plus this angle. So if we do that, we'll get 50 plus 19.9, which is going to give us what, 79.9? Am I crazy or is it 69? Yeah, it's 69. I'm losing my mind. All right. So as you can see, that works because that's less than 80 degrees or less than 180 degrees. So that works, first of all. Now we'll have to test out 160. So 160.1 plus 50 is going to give us, what would that be? 210.1. So as you can see, that is not possible. We can't have two of our angle measures give us more than 180 because a triangle has to be 180. So that doesn't work. 160 is not an answer. Our only answer here is 19.9. All right. I'm going to show you one where it's no solution. That way you can see it. I think on number 8, I think we're going to work this one in class. So I can show you what happens when we have, in number 8, essentially what happens, you can go ahead and work it if you want. Essentially what happens is you get two answers that actually work. So it's two answers that actually are added together and are less than 180, or the angle measure of your triangle will be less than 180 for both, so you have two solutions. But I want to show you the no solution just so you can see what it looks like. So let's look at that. So number 10. So number 10, we have a triangle ABC again, and I'm going to try to draw it for you. I always draw it the same way, and I say that this is A, this is B, this is C. And we're going to fill in what they gave us. So they gave us angle A, which is here, is 114, so that's going to be 114. They gave us AB is 34, so that'd be right here. BC is 12, so that'd be right here. Then they want us to figure out what this is, so we're going to call that X degrees. And then we're going to set up our law of cosines, or law of sines ratio or proportion. So we're going to take sine of 114, and we need the opposite side of that, which would be 12. If you will go away. Okay. So that'd be over 12 equal to, then we're going to take sine of x, because that x is filling in for our degrees, over the opposite of that would be 34. So over 34. Then we're going to cross multiply. So we'll have 34 sine 114 equal to 12 sine x. So then we want to get rid of this 12. We want to get sine x by itself first. So that's multiplying by 12 on the top. So we want to divide by 12 on the bottom on both sides. And we'll get rid of 12 over there. Then we'll get sine of x is equal to 34 sine 114 over 12. Now, like I said, I want you to go ahead and plug this into your calculator. So plug this into your calculator and round up to 4 decimal places. So you'll get sine of x is equal to 2.5884. Now, just like we did with in 10.2, at the end of it, whenever we have sine of something, which here it could be sine of theta, sine of x, whatever, sine of something, if we don't know what's actually there for our angle measure, or for like our radians, which I guess would still be angle measure, what we do is we take x and we set that equal to the inverse sine of whatever this is equal to. So it's equal to 2.5884. So that will give us x is equal to, I actually think when you plug this in, it gives you no solution, which that's the 0 set. It actually says error when you plug it in. So that means that we have no solution here. So when you plug that into your calculator, you'll get like an error or something like that. Now make sure if that's popping up, you didn't do something wrong. But if you double checked it and you didn't do anything wrong, it's no solution. So that's not going to work. So this problem here has no solution. Now, if we would have found this angle here, or what the angle could be, and then we added it with 114, and it was more than 180, then it would be no solution as well. So I don't know, a few different things could happen here. So we're going to do number 8 in class just so I can show you that one. I think it'll make more sense if I explain it in person, hopefully. All right, so that is law of sines.